Teach me now. Now we have grade 12 probability counting principles. Okay, so we have ping pong balls which are numbered 1 to 12 and are placed in a hat. Every time a ball is drawn, it is placed on a rack, one next to the other. So 11.3.1, how many different arrangements of the 12 balls are possible? Remember, this is just simply 12 factorial. So this is 12 factorial, which is 479,001,600. Okay, and then 11.3.2. Assume that the numbers 8 and 11 must be placed next to each other. Okay, so where the 12 factorial comes from is that you have 12, let me explain it over here. You have, for 11.3.1, you have 12 spots. So now for the first spot you have 12 choices. Here you have 11 choices, 10, 9, just like that until you have one spot left. But now you're going to multiply this out, 12 times 11 times 10 times 9 times 8 and so on. So now instead of writing that, you can just write 12 factorial. Okay, and 11.3.2. So you have that number 8 and number 11 must be placed next to each other. So this means now that you are taking 8 and 11 as a set. So let's say you're putting them in a box. But now, in this box, how will they be placed? You have two spots, so you have 2 factorial. For the first spot, you have 2 choices, and for the last spot, you have 1 choice. So that 2 times 1 is just 2 factorial. Now that you have one box for ball 8 and 11, which are placed next to each other, you must then now place them with the rest of the 10 balls. Remember, you had 12. You take 8 and 11, you place them next to each other. This means that 2 are next to each other. So now you must place this box with the rest of the 10. So this means you have 11 spots now. Okay, and if for the first spot you have 11 choices, for the second one you have 10 choices, for the third one you have 9, and so on and so forth until you get to 1. And instead of writing this out, you will just say 11 factorial. So now don't forget that for the first 2 balls, which are ball number 8 and 11, they were supposed to have been placed next to each other. So we must account for that 2 factorial, which is equals to 79,833,600. Okay, and then 11.3.3. You have the numbers 2, 5, 6, and 9, which are taken from the group of balls. 2-digit numbers must be formed out of these 4 numbers. How many 2-digit numbers can be formed? So you have 2 spaces and you have 1, 2, 3, 4 numbers. So for the first spot, you have 4 options. For the second spot, you have 3 options. So 4 times 3 is just 12.